Welcome to the Meltzone podcast. This is episode 42 from February 1st, 2021. I'm Tom.
And I'm Stefan. And on today's episode, we are not only talking about why Tom's hair is missing, but there's also a lot of talk about, 3D printers in general. So, I'm currently doing my VORON build. There is a new Kickstarter printer called the Plybot, which has connections to Brook Drum and the old printer board. There is the Fuse one from Formlabs, an SLS 3D printer that is finally released after years and years in development. We are talking about low-cost metal 3D printing using basically electrochemistry and electroplating method, and a Prusa that had a fourth axis added to it, which supposedly is able to print parts without any support structure if the parts look as what the printer can handle. And then also just a bit of talk about the current GameStop controversy and short selling things and hedge funds and everything, which is connected to that.
Stonks. On other news, there is yet another startup doing meatless meat through a 3D printer, adding some texture to it. We talk about whether that's actually something we need. Well, we do. And also, as a feel-good topic to close out the recent events, there is, 3D printing is really useful, not just for 3D printing, but we're seeing a lot more interdisciplinary use of the stuff we do here. And for the questions this week, we talk about whether or how SLA printers actually work and why they're not just curing stalagmites of material where you previously tried to cure something. Why does it stop at the layer height? We look at what options there are for closed loop systems to drive a 3D printer, and a quick back or behind the scenes look at what we do to record these and why Stefan actually looks so good in these shots.
Tom,
Stefan,
your hair,
it's gone.
It's gone. I was so shocked. I was so shocked.
Yeah, actually, let me show off the full. Yeah. Oh, the headphone. Yeah, but
it's all gone.
Yeah, there's more hair in my face than on my head.
Yeah.
You just gotta do what you gotta do, Special times call for special measures, and it's just been getting annoying just having hair fling around.
It was a pretty brave move you did there, and it was just totally unexpected. I was sitting there and I just didn't know what I could say.
Yeah, I mean, like I tweeted, I think that's going to be hard to beat as a sponsor transition.
Yeah,
sponsor segue. Yeah.
Hope they pay you enough for that.
they're decent.
Well,
they're decent.
Yeah.
Trade coffee.
Maybe you'll trade coffee.
They don't ship to the EU.
They don't.
No.
Besides to Thomas Sandladro.
They actually do not ship to me either. So I've actually had to go through Joel, 3D printing nerd. I was like, hey Joel, there's 2 packs of coffee in it for you. Can you forward this to me?
Okay.
and I sent him the FedEx shipping label, and he FedExed it to me. Because trade coffee don't even ship to reshippers. So yeah, I don't know. Last time, so for some reason they managed to do it. Now they're just like, well, I don't know. We can't. So
that's interesting because, well, you as somebody who's gonna promote that, why can't they just put another shipping label on there and just send it off? I don't know if that's import regulations they really don't want to mess around with.
I don't know. I guess it's because it goes through an agency, and I don't know. So many different intermediaries between that. I don't know.
But maybe speaking of import problems, I had a Dan from Slice Engineering sent me a mosquito hot end for my VORON build 3 weeks ago, and it has been sitting for almost 2 weeks now in the import office at DHL. I don't know, just because it's properly declared, because everything I usually get from Asia arrives here in like 3 days. No questions asked.
Do you have a, what is it called?
EO?
Generalverzollungsauftrag
Yes, I
with
do.
DHL. Okay.
Yeah.
Okay. That's weird.
Interesting.
Yeah.
I'm basically calling them like every second day, and they just say, Brexit problems,
Brexit
COVID.
problems? Okay.
I think they need to deal with a lot of stuff either coming from the UK or going to the UK, and probably coming from the UK, that they're just overwhelmed because they don't even know what to do with it. But yeah, that currently really annoys me, because I would like to progress with my build, but I don't know if I should put the V6 in there. I also have, but I definitely know as soon as I put the V6 in there, I get the other package delivered. But yeah, that's currently pretty bad. Do you know if Prusa is shipping again to the UK?
I don't know if I've heard any updates there. I think they've just ceased shipping to the UK. I mean, yeah, Brexit's going well, but that's an entire different topic. Yeah, but for imports, I mean, FedEx been everyone in the US seems to complain about FedEx a lot, but FedEx for me has been fantastic. Like, just delivery times and the way they deal with imports, they're not cheap by any means, but they're really reliable for me. DHL Express has been giving me issues every now and then.
Yeah. So I think FedEx is like the only company that already lost 2 packages that should have arrived, and there is a delivery signature from someone who doesn't live around here, and then you don't really get a response when you write, oh yeah, we're working on that. Never heard from them like for a year, so I don't know.
Okay
Yeah,
so they're all crooks. Fantastic.
Yeah, we'll see.
Yeah, so how's been the progress on your VORON build? I mean, I've been... When did we talk about this the first time? 3 weeks ago?
Like 3 weeks
and
ago?
It's already built? Like, holy crap, that's quite the pace. Yeah, I've seen the tweets. But
it's a beautiful machine. So, well, you said just build a VORON. I never heard of VORON before, and I'm totally sorry to say that.
I'm just echoing what everyone else is saying.
Yeah, I did some research, maybe not enough research, and I've seen that like their VORON 0 basically fit exactly in that description we talked about. I said I wanted to have a really small, really fast 3D printer. The VORON 0 is 120 by 120 by 120 build volume, which is tiny, which I think you only start noticing when you really see it.
I think most of my parts would actually fit into that volume, though.
Yeah.
Like, you can get a surprising amount of stuff done with a small printer.
The interesting thing is the build volume of the VORON 0 is big enough to print all of the parts for the VORON 2, which is like the really big one.
Yep.
Yeah, so I didn't want to source the parts all on my own. Don't have the time and the nerves for that. So I found a pretty decent, not really cheap kit on AliExpress from Formlabs, which I ordered. It was also horribly expensive to send over, $50 or something like that.
Yeah, if you want it within a couple of days, then sure, yeah.
No, they actually don't really offer like the cheap Chinese standard shipping options. It's you get $40 for FedEx and $50 for DHL. Okay. So yeah, it arrived in around a week, and I just couldn't hold myself back building it because I just enjoy that. I think it's the same with building Legos when I was small.
But you're not doing build live streams or videos about the project or anything, right?
I thought about doing a building live stream for the VORON, but I'm totally happy that I didn't do that, because that thing is small, which also means that the screws and everything you put in there is really small. And I think I've already been working on like just the mechanical build for 6 hours or something like that. But it requires my full concentration. I would not have been able to do that on a live stream. No way.
It's more enjoyable to do it without, the pressure of an audience watching too, right?
Yeah. I filmed some of the parts, which I want to show in a video later, but not really like a full build video. It's nicely designed. It is a bit fiddly to put together, to be totally honest, but so far it went together well. And with the like black carbon fiber parts, it just looks so awesome. So yeah,
for sure. And it's a Core XY, right? Just Core XY on X and Y, and then Z axis is belt driven, or
no, it's lead screw driven. Okay. I think there's a mod for making it belt driven, because some have issues with Z banding, but we'll see. The really nice thing about the kit that I bought is they are using, quite high quality components. So LDO motors, triangle laps, hot end, Omron, SSR, and Meanwell PSU and stuff like that. So I'm not really upset that I paid $400 for the kit and the $50 additional for shipping.
Right. But what's included? Is it really everything except for printed parts? Like, do you get screws, wires, that sort of stuff?
Yes.
Okay.
It's everything besides the printed parts. So pre-machined extrusions, lasered out acrylic parts, belts, screws, hot end electronic components, everything. You still need to solder a bit here and there, but it's basic. You basically just need to print a couple of parts, and then you're ready to go. Still didn't finish all of the electrical stuff. That's something for this week probably. But yeah, so far pretty nice, and it just looks great. It really looks great. I don't know if it's really worth the $500 you pay for it in the end, but
I mean, you can always make that argument, right? Is it really worth that much extra? And does it really print that much better? But it's nice to have a printer that is just solid every now and then, because as I've got the Mark III right here on the table, and that's not that solid of a printer. It does more in the way of being built like smartly and using parts in an intelligent way, but it's not like, you could, that Mark III would be bent after that if you did that. Yeah. So, it's just nice having a printer where okay, the mechanics, everything I did is just bulletproof. Like, that's never going to be an issue.
Yeah,
that's nice.
Well, my primary goal for this one is printing a 10-minute Benchy.
Oh yeah, I mean,
I'm
talked about that.
I'm quite excited to see how far I can get with just the basic setup. And having a mosquito hot end in there. And I think from that point on, I will try to modify it to get my 10-minute Benchy, because that's the big goal. And printing a 10-minute Benchy, I simulated that in Prusa Slicer, is not as easy as you think.
You need pretty good accelerations.
You need pretty good accelerations, and the material you need to melt, you need to have like 20, 30, 40 cubic millimeters a second of material going through your nozzle.
Which is not impossible, actually, but the thing that I did run into trying to push my printers is just cooling. So I assume you're not going to be printing with PLA.
That is the big question. Many are printing with ABS, and I don't know, ABS with additional cooling might be an option, but this is actually I really want to play around with. There are some... This is one of the things I want to investigate. You need high flow materials, and PLA is not the best flowing material. ABS has, I think, a way higher melt flow index, or
You can get
significant.
the way different ABSs for that, yeah.
Yeah. But then also cooling, yeah. If you don't have like a ton of cooling, you just print a big blob. Yeah. Adding compressed air cooling might be an option. I don't know. This is exactly what I want to find out. This is the challenge for me.
The Benchy is now crooked Benchy. Just blow it over. Yeah. Sounds really interesting. Cooling, melting. It's that there's so many things that go into like pushing a printer past what it does typically, and the reason why I always recommend, hey, if you need better print quality, or if you have issues with your printer, just go a bit slower. It's because you do run into so many different things if you try to push it.
That's going to be the challenge.
Yeah.
We'll see.
So hot end for that plan is the Mosquito or Mosquito Magnum.
The Mosquito Magnum, because I think the Mosquito also can go, I think, up to like around 15 to 20 cubic millimeters a second.
You should easily be able to do it, yeah.
If you want to go higher, you need the Magnum. It's basically just replacing the heat break. I also bought. So Dan has been shipping.
That was my heater, sorry.
Dan has been shipping me the Magnum hot end. But I think I'll start with the standard heat break just to see what is limiting me in the end, and then change components, maybe change stepper motors, tune firmware and stuff like that until I get to my 10-minute Benchy.
There's the Mosquito and Mosquito Magnum. So
the Mosquito Magnum just has a different heat break. It's the hot part is a bit longer, so the heat break starts later.
It's got a copper slug going upwards from the heater block. I mean, the heat break might actually no, it's different. But yeah, it's interesting because on the E3D Volcano, like you have your heater block extending downwards. On the Magnum, you just have it extending upwards.
Yeah.
So yeah. Well.
Yeah, I think I wouldn't be able to put a Volcano hot end on that machine, because that would be flopping around so much and would just add additional weight. And for this reason, I was looking for the Mosquito. So
yeah, and I do really like the way that it's built with the 4 extra standoff tubes. It just if you crash, this is not gonna feel the impact on a Volcano. Yeah. Well, maybe you're gonna need a new heat break.
Yeah, Super Volcano, even worse.
I think I bent the heat break on my Super Volcano like on the first or second print, and that was on a Mera. So
yeah. So it's not really easy to get a replacement heat break for that.
Yeah, gonna be interesting.
Cool. Yeah, I'm looking forward to that. Maybe speaking of 3D printers.
What else do we talk about?
Speaking of 3D printers, let's talk about the Plybot.
Yeah, let's talk about the Plybot, because that is that one that could do fast printing?
So what's the Plybot?
Yes. Plybot. Okay. The Plybot is a Kickstarter project, which I'm usually skeptical of, but it has Brooke Drummond involved, which you guys might know from ventures like Printerbot. Printers I very much like. So Plybot is a new printer that has what is this called? A Skara? Skara-like? Yeah. I mean, I've seen the Skara where it's 2 joints in series. I can't, like this basically has one rotating joint and then another rotating joint. But this is 2 arms, and then basically each of those arms has a rotating actor, and you get the intersection between that by rotating basically the shoulder joints. So it's that on the XY, and then the X's I think is just something classic, basically. Yeah, lead screw driven. Yeah. Looks super interesting.
We haven't seen that many Skara printers, at least commercially, in the past, I think.
Were there any?
Well, I don't know if there were any commercial ones there have been maker projects in that direction. The question is now, why Skara?
I think
I guess.
Go ahead.
I think it's cheaper. It might be cheaper.
So okay, it might,
or is it just because it's different?
That was going to be my point too. I think first and foremost, this is something new to try out. We've seen Skara designs before, but not this exact Skara design. And I think for the most part, this is something where they want to experiment and see, hey, maybe we can learn something from this and see how we can apply it to different machines maybe, or what applications this is really good for. I've thought about like what mechanical advantages you could have with a system like that. And I guess that the first one would be, if you're printing straight XY lines, you're not going to get any sort of, or even diagonals, you're not really going to get a repeating stepper pattern or a tree ringing that would line up with the axes. Because it's basically your resolution is like two intersecting circles or something along those lines. So whatever resolution issues you might have, it's going to be hidden in dithering, basically. The other thing I thought of is you don't need a super high precision mechanical setup, because your arms, they're pre-tensioned by gravity or biased by gravity downwards. So even if you have slop in your bearings, they're always going to be loaded in the same way. So you always have them like sitting on one edge. So you might get very consistent positioning with that sort of a system, even if the
this is one of the things I was really concerned about, because if you have slop in the bearings, I could imagine that positioning might not be that precise. And I don't know kinematically how the resolution is all over the build platform, or if there are positions where you kind of are in an indifferent state, where just a slight force, where like the positioning system can't really push the motor to a specific location. I don't know if I explained that properly, but just with the arm system, I could imagine that, for example, the middle position might be a bit sloppy because I don't know.
Yeah, I mean, I see what you're saying. The resolution throughout the build area is definitely not going to be constant, just like with a Delta, where you have different resolutions per se across your XY space. How much of a problem is that going to be, since it's not really aligned with your XY? I don't think that
it's a huge problem, and with micro stepping we have nowadays and 32-bit control boards that can hammer out steps really fast, I don't see that you get a resolution problem. I would just be interested to know how stable the kinematics really are. It's interesting because kind of similar to also the printer bots, it's a very clean and minimalistic design.
I'm a bit worried about dynamic forces. If you look at the z-axis, it looks like it's just two 8mm rods and then a TR8 in the center, and the backing plate where the spool mount is on is just sheet metal. Like, there's no structure there per se. So the tops of your z-axis are supported in the X direction, but in the Y direction they can basically freely flutter around, so that they're only held in the base somehow. And that's something that Printabot has always kind of done that way, but it doesn't always make for the most rigid machines. Dynamic forces in the Y direction should be fairly minimal, though, because you don't really have, like, on the Printabots, obviously the entire Y-axis was extending out, but there shouldn't be. Like, it's just the hot end that you're lugging around, right? There's no real weight to it.
No.
So
one thing that, well, which makes the design look really clean, but was concerning me a little. There's no part cooling fan.
Oh, you are right.
There's no part cooling fan with the machine. And the hot end itself looks like the first hot end I got on my Mendel 90, which had the peak heat break thing.
Yeah, it's a Ubis something. I don't know if it's a Ubis 13S or whatever the most current one is, but it's the same style Ubis hot end that Printbot has been using for a while.
Okay.
They work fine.
Okay. Yeah, well, my Mendel 90 also always worked really well. It's just interesting to see that you have, well, it's interesting to see one of those kind of older designs back in a new printer.
As far as the hot end goes.
As far as the hot end goes, yeah.
Well, it's a design that's, so the Ubis hot end has been updated over the years. So it's, okay. I believe right now it is an all metal hot end, or mostly metal, and the peak isn't really that thermally strained.
Okay.
But yeah, it's a modern updated design. As far as the part cooling fan goes, I just looked through the specs. It does have a part cooling fan. It is Z-axis mounted, so it doesn't move with the hot end. But let me see if I can actually find where it is.
Okay.
If there's like a tube going towards the hot end, or if it's literally just blowing over the entire build area. Honestly, I can't see it in any of the pictures here. Let me
yeah, I can't see it either.
So there is it's okay. So the prototypes they're showing doesn't, unless they're really hiding it somewhere. But well, I guess they do have a part cooling fan somewhere. You
could potentially like use the arms to duct, well, as ducts for cooling air. Because they're rectangular and they don't have anything in there. I don't know. Could be. Maybe it's an interesting design. Maybe they just didn't show it on the pictures.
Yeah, the renders don't have anything in there either. I can't find. Okay, but it's they say it's got a Z-axis mounted part cooling fan, so I trust that it's in there somewhere.
Yeah.
Or at least on the shipping machines.
One thing that also concerned me is their printing software, which is cloud-based. I hope they allow to just put SD cards in there or USB sticks. I just hate proprietary printing software.
Right. Connectivity, Wi-Fi, USB, SD card.
Okay.
So if this is based on Printbot Cloud, then they already have something that kind of worked. Like Printbot Cloud on the Printbot Pro was, well, it has definitely been shut down since the printer shipped. So that's obviously something you're going to run into if you just have a print that fully relies on just being a cloud-based printer. But yeah, with this one just having USB and SD card support out of the box, that shouldn't happen.
Okay.
And if anything, I would see it as a bonus.
Yeah. It's not funded yet. They were aiming towards $50,000. Still has like a good month to go. So, unfortunately, we in the EU are not able to back it. They are only shipping to the US, because I really thought about backing it just because I did never have a printer bot. It is an interesting design. I hope that it works. It's something different. So, but yeah, no possibility. I could, well, Joel offered to send them over, but I don't know. I still need to decide whether to do that or not.
Yeah. I mean, with probably, if you or me reached out to Brooke, he'd be able to arrange something. It's just I have a policy of kind of avoiding or not covering Kickstarter machines on the channel in general. So it would be breaking that rule if I now did something on the Plybot, and once it actually ships or has shipped all the backers rewards, like nobody's going to care about it anymore. So that's the limit that I'm in here. But
Well,
yeah, it is.
I
Go ahead.
this wasn't really my goal to do something before the parts are shipping or before the printers are shipping, but maybe just to back it and have one once it really ships, one to have one of the like the real units. So that shouldn't be against your policy.
Well, just to have one for myself, sure. But,
Yeah.
you got to remember I'm doing this full time. So when I'm doing something on 3D printing, I better make a goddamn video on it. Because otherwise, like, what are you doing with your time? Right. So yeah, the printer is $299 as the early bird reward, which is pretty good. I mean, I think that's the same price as the original printer bot, the wooden one, or was that $399?
Don't know. Do you know if it is made in the US again?
Ooh.
Because $299 is like the early bird. I don't know, the later price is $330, which is not early bird anymore. I don't know if retail is probably going to be $350 or even $399, which already puts it in a spot where the Prusa Mini Plus now is, and also some others more expensive printers.
Manufacturing your plywood locally is important to us. By keeping manufacturing close to our home, we keep a keen eye on the quality and ensure that there are minimal production delays. So it is lovingly made in the USA. So made with love in California, which Printbot is from Sacramento. So it's that same area, I guess. Yeah, but I don't want to give off the impression that this is just. I should have put my phone on airplane mode. Sorry. I don't want to give off the impression that this is just Brooke Drum. This is also Josh Mitchell, and Ian Wilding. So it's a three-man team that are doing this together.
Yeah.
Just wanted to point that out.
Yeah. When are they planning to ship it?
So the early birds are planned for June 2021, and the regular birds are planned for September 2021.
Okay, so we'll probably see something until the end of this year if circumstances don't change, which currently they do a lot.
But yeah, I mean, like I said, that they're building on the experience of Printerbot. So I feel like they've kind of got most of the manufacturing figured out already. So
yeah, I don't know if it still looks like an all metal construction, or if they're, for example, using injection molds for the arms, which is an investment, and things they.
Yeah, though I mean I think the interview with Brooke is on my channel somewhere, but Printerbot tried to do everything in house. So they started out by having a laser cutter and doing their sheet metal parts in house. They tried to do PCB assembly in-house. They did injection molding in-house. So they milled their own injection molds and then did the injection molding themselves for Printerbot. Eventually, that was maybe a bit too ambitious, which is why Printerbot doesn't exist in its original state or in its original form anymore. But I wouldn't be surprised if they learned from that and maybe took a bit of a refined approach to how they manufacture things, and now know, okay, we can do, let's say, injection molding, but if you do this and this and this ourselves, we can still do a cost-effective and on-time version of that.
Yeah.
So
let's see. Maybe just quickly, speaking of circumstances that change, Murph is still up for March 26th until March 28th, 2021.
Okay.
I think we
as a physical event?
As I think a physical event, yeah. As far as I know. I
questionable.
don't know if it's really gonna happen. I don't think that we even would have the possibility to enter the US under current law.
I think on like business trips and stuff, you may be able to, but it is. First of all, it is a questionable move to even like attempt to have a show like in March this year. Yeah, and it is also questionable whether it's actually going to happen. Though, as far as I know, the US aren't as strict in their regulations, like what can legally be done and what cannot be. Whereas here in Germany, it's like, well, no, it's just you're not allowed to do anything like that. And I do agree with that regulation, but yeah, in the US apparently you can still plan for things like that. Even if I was able to attend, I wouldn't go. Like I think
neither.
I think my reasonable plan of events is get vaccinated and then look at what the situation is and only after I've gotten 2 doses of the vaccine, it's like, okay, now you can maybe think about doing some things again. Before that, it's just my decision is just, okay, it would be unreasonable to attend like mass gatherings like that.
Yeah.
So
same for me, unfortunately. It was already almost 2 years ago when we were at Murph, and
yeah,
really miss it. Really miss the time.
2020 went by so fast.
Yeah. Good thing that it did. Yeah. Shall we stay on topic of 3D printers and quickly talk about? Sorry.
No. Actually, since we're off topic, let's do this one. That's actually it that I put in as like the starter topic that we didn't manage to do. Did you buy GameStop? Did you buy some GME for yourself?
No, I did not. I never bought any stocks.
Okay. Well,
I don't even have a large amount of Bitcoin or something.
So you don't even have Bitcoin. No, I don't. I did not buy GME. I heard of the entire thing going down when it was already at like 200 per stock or something. So that was the point where I was like, okay, now this would be stupid to invest now. But it's an interesting, series of events that's going down. And I've actually linked a Spiegel.de article. Apparently, Melvin Capital, who was one of the major short sellers on GME, has lost half of its capital. Just how naive do you have to be to make those bets? Because I mean, investing in stocks is betting, right? It is that's all it is. They lost how much?
Couple of billions, I think.
Yeah. Like single digit billions.
Well, I think usually if you do something like that and like price raises by orders of magnitude is something that you don't really expect. So they were doing their thing as they did usually, and even bought more, or even short sold more stocks than there are available.
Yeah, it was like 140% of the available volume. It's to me that feels like drunk driving. Somebody might go drive home drunk every week, and it's like, well, it's been fine, and all of a sudden he gets into a car crash and it's like, oh, I would have never thought this. No, it's just stupidity at that point. It's always been stupidity, and at some point it gets punished.
The question now is now short selling getting more regulated, or is it community gatherings are getting more regulated, and I don't know.
That's going to be interesting.
Penalize those. Is it penalize?
You do use it. Depends on where you're from in the world.
Okay, good. Penalize the ones that made the stocks go up. Is that market what's the word?
Is that manipulation?
Market manipulation. I don't know. I don't feel bad for the hedge funds because they made billions from doing this in the past and ruining companies that way and ruining small investors that way. So, but in the end, who has a lobby? The small investors or the big hedge funds?
We will see. Yeah.
We will see.
So is it market manipulation? I mean, yes. I mean, something clearly happened. So the market was manipulated. So the market was influenced by that. Let me go on a bit of a wider arc here. In university, I had the opportunity to do a stock exchange license. I think it was something like that. Basically, as if I remember correctly, I'm allowed on the actual trading floor of the stock exchanges by having done that. And basically, it covered everything from these are options, these are certificates, these are stocks, shorts, longs, yada yada yada, full thing. After I did that course, I was like, okay, I'm not touching this shit. This is gambling, and I don't gamble. And that has worked out pretty well for me so far. And that position is being confirmed over and over again. Like it's just betting, and you gamble, you win, you lose. The only way you can really succeed on stock is if you have information that others don't have, which typically is insider trading and is legal. So for the normal human being, I think you can make a lot of money if you're lucky. But you can also lose a lot of money if you're unlucky. Where was I going with this? Where I was going with this. Anyways, yeah, I personally, I do hold stock. I have the MSCI World, which is like the only reasonable thing I think you should be holding. Basically, ETF of the entire world's economy weighted by value. So not much can go up and down there. The point I was going to make. The stock market is not something where you make money or where you create money. It is an exchange, and not just exchange of stock, but also exchange of capital. So if you make gains, if you make a profit, somebody else is making that as a loss. The stock exchange doesn't create value from nothing. It is literally just an exchange of, you gain some, someone else loses. If the hedge funds make money on something, somebody else is losing that money. And back to the point of having more information than the opponent, usually those people that lose money are those that have less information than others. So yeah, it is for a certain extent, just the stock market is just preying on those that naively invest. Whether that naive entity is a hedge fund or just millions of private investors, that depends on the exact time frame you're looking at. But yeah, it's somebody loses, somebody else, or somebody wins, somebody else is going to have to lose for that.
Yeah.
It's interesting for sure.
It's interesting. I've never been a big fan of stock trading, so I just don't really want to touch it.
Yeah, I mean, for me, I've looked into, hey, what are the options? How can you invest the little money you have? And it's like, well, first of all, you put as many solar panels on your roof as you can. That has been the number one, and that has worked out fantastically. Number two was like, hey, do you get like one of the Riester-Rente options you get? But it's like so many of the state subsidized investment options are just the banks make all the subsidies, and you're just left with basically a Sparbuch, like zero interest, and all the fees from the bank eat up any incentive you might have in that. So for me, it was just like, well, guess I'm buying some MSCI World, and so far that's been okay. But I mean, I'm not one to give to give investment advice here.
Yeah, no. Well, we put a third floor in our house. That was my investment.
That works too, yeah. Invest in Immobilien.
And now I need to save for the baby's education.
Yeah.
And I don't know if I want to gamble with that education money.
Yeah. Well, before we get too deep into this, and before I get you convince you to make poor decisions, let's move on.
Let's move on. Yeah, let's continue on 3D printer topics, like physical 3D printers.
Yes.
Formlabs finally released their Fuse 1, which I have seen, I think, the first time 4 years ago on Formnext, and was pretty hyped because I think at that point, the Formlabs Fuse 1, which is an SLS 3D printer, so you basically melt nylon powder with a laser, was a machine that was teased for $10,000. And even though $10,000 sounds quite expensive, the other machines that were available at that point from, for example, EOS, usually started at $100,000. Unfortunately, for the last 4 years, the machine wasn't really released. You could pre-order it, but it just
so the
wasn't
Fuse
released.
one.
And the Fuse one, the Fuse one wasn't released. There were some others like the there's a Swiss and I think one Polish company,
Syntratec and
Sinterit.
Sinterit, yeah.
Yeah. They also released budget SLS 3D printers, which I think the cheapest one even starts at $5,000, and
that's been out for a while.
You need a couple of equipment on the side to sieve the powder, to mix the powder, to depowder the parts and stuff like that. But they were also like available. But yeah, now finally Formlabs released their Fuse 1, which is not $10,000 anymore. I think it's $15,000, and with the additional equipment that you need on the side, you look at I think $25,000 US dollars all in all. Which just shows again that SLS 3D printing is not only having a vat of nylon powder that you like melt with a laser. There is way more to it.
And I don't think that's ever going to come down in cost much, simply because of you dealing with powder, and that is a material that is not easy to handle. The powder also, they're claiming a 70% powder refresh rate. So basically, if I understand it correctly, like you're able to reuse 70% of the powder in your next job. Because I know from metal powder, from metal printing, like it's all being kept at temperature and all that, but also I think it's the same for SLS too, right? You keep it at a temperature that is high enough where it doesn't sinter, where the individual particles don't bond together, and then you just add that little pop of energy to the spots you want to sinter, and it just pushes it over that point where it becomes a not necessarily solid, but a part that sticks together. So the powder itself also degrades just by being exposed to that elevated temperature over time. So you have to basically throw out 30% of your powder and add in 30% virgin powder again for every job, basically.
Yeah. And the thing is that the powder is pretty expensive. I think if you take a look at Sinterit or Sintratec, you pay 100 to 200 euros per kilogram of powder. And that is also important when you think about just printing one part at a time, or really, I think the term is called nesting. When you use that machine, pack as many parts as possible into the machine, because 50% of the powder that needs to be used, because you always need to have like a full powder container. 50% of the powder that you even didn't melt or didn't sinter, you have to basically throw away.
Or 30%
because you always
in
need
this
to
case,
add
what they're claiming.
Yeah, exactly. So this is pretty interesting that they lowered that amount, because that also makes using the machine cheaper in the long run. But yeah, it is interesting. Just maybe on a side note, for metal 3D printing, it's a bit different. For polymer SLF 3D printing, you really keep the material at a temperature which is close to like when it starts sintering or even when it starts melting. And I think that just degenerates the powder, as you just said. For metal 3D printing, you usually elevate the temperatures a little bit in the building chamber to fight moisture in the material, and for some materials, for example, aluminum, to decrease the warping tendency of the parts themselves. Yep. But the melting temperature and the temperature in the chamber is quite high, so we have a pretty high gradient in there. It would be good if like the build chamber temperature and the melting temperature would be pretty close together, because that would reduce stresses in the parts and the process itself. But since the temperatures you need for melting metal is way higher, the machines would get way more expensive. Yeah. And well, yeah. So for metal 3D printing, you usually have everything in inert gas atmosphere, and the powder doesn't do a lot. It might just take up some oxygen and stuff like that. So usually you just sieve it, and you can reuse the powder for quite a while.
Yeah, I mean, I did work with One Click Metal just on getting a few videos out with them, and we obviously talk about like what their machine is doing differently and all those things. And yeah, I got to see the process, and it's metal 3D printing. Like, don't make the mistake of thinking, oh, we now have a cheap already in quotation marks SLA printer for nylon or PA12. Like the next step obviously is we just increase the laser power a bit and we can now print metal. Like, it doesn't really work that way. And I think the One Click Metal system was like 50 grand for like we're going for that price. If we can make it, we can possibly make a machine for 50 grand, and that is incredibly cheap for a system like that. And people still commented, what do you mean that's cheap? Like, that is freaking expensive. And yes, it is expensive if you're comparing it to an Ender 3, but it is cheap for what the machine actually does. And
the laser power that is also required for metal melting and for those SLS polymer machines is really different. For the polymer machines, at least for the like more expensive EOS machines, I think they just use CO2 lasers, which cost nothing. For metal 3D printing, you need different wavelengths. So usually just a near infrared IR laser is used, and those are fiber lasers, and they already, for example, for 400 watt fiber laser, it will set you back $50,000 or something like that.
Yeah, and that is one of the core things that, you know, designers of low cost metal machines also try to work around. But yeah, that's that. It's like metal printing at the home is not coming to us anytime soon. The metal powders are extremely dangerous to work with. First of all, you know, if you have anything that is flammable, it gets significantly more flammable if it's in powder form, just because you have so much surface area. And also, you don't really want to breathe it. So if you ever work with metal powder, like full, you know, mask, keep it contained, everything. Do you know if that's similar with nylon powder? I would think so.
It is. I would say it's pretty similar, because also if you inhale nylon, and I don't know how big the particle size is, but I guess there are particles in there that can make it into your lung. It's probably gonna stay there. So it's the same for both, and I sometimes really ask myself, why are companies allowed to show their SLS machines open and depowdering on exhibitions just on the normal floor? Because also that stuff is kind of nasty.
Why are they allowed? I guess because the show organizers don't really know any better, because they typically don't have to deal with exhibitors that, you know, emit fine particles.
Yeah. Then you could argue, there's for ages there's microplastic in our air, so doesn't make it really worse. You should use safety precautions for both. For metal 3D printers, it is sometimes even more dangerous because you have, for example, you're using heavy metals like nickel alloys. Getting nickel into your body is not really healthy. Aluminum is deemed to be causing cancer. So for all of that stuff, you would additionally say, okay, you need to have safety precautions to not get that into your body. The nylon probably is pretty inert, but still I wouldn't like to have it in my lungs.
Yeah, well, anything that is a particle that gets down into your lungs, that's not healthy, whether it's metal or nylon.
Yeah.
All right. So that is the Formlabs Fuse 1. I mean, just for context, Formlabs is a resin printing company. That's where they came from, and kind of like Markforged that did the carbon reinforcement. They are now going into a new area, going into SLS. So interesting to see what other manufacturing processes the various companies go into.
No, I find it really nice what they're doing, because they were always the company that made resin printing easy to use and also kind of clean to use. And I hope to see them doing the same thing for SLS 3D printing, because it wasn't really affordable in the past. And the process is kind of nasty, but if they have a nice powder management system, depowdering station and stuff like that, you could have something like that in your workshop.
Yeah, well, at least
workshop.
You can minimize the risk involved and the PPE requirements for using that machine.
Yeah.
On the topic of novel processes, we also have a low-cost metal 3D printing approach in our notes today, and that is an article on Hackaday, though I'm sure it's been covered on various other sites as well, which prints metal using electroplating. So, who is it? Billy Wu is calling it Electrochemical Additive Manufacturing. EAM. I guess you could abbreviate it. So you put that in there. I don't want to get it wrong. You've probably read on how exactly it works, right?
It's probably just electrolysis. It looks like that they're just depositing copper using a small syringe, where they, I think, slowly just release maybe a copper sulfide solution. Yeah, I think it's copper sulfide, which then is depositing at the location of the nozzle where you have the potential difference between the anode and the cathode. And this way you can potentially 3D print metal parts very slowly, I guess.
Oh yeah.
But I think it's a quite interesting approach, and I don't know if it's just usable for pure metals, but for example, having a pure copper printing process that is also kind of simple is really valuable for applications where you look for heat transfer or conductivity or things like that.
Yeah, so the basics of electroplating, I guess, is for those of you who've never done it, I've dabbled into that a bit, and it's interesting. Basically, you need a couple of things. You need an anode, a cathode, and you need some solution that has your metal dissolved in it in a way that is suitable for electroplating. And you apply a current from your, I always get these wrong, from your printing tip in this case, I guess, and the electrons basically carry your metal atoms, your particles, onto the surface of the part you're plating. So you're basically depositing that onto the surface, and it bonds well enough that it is it forms a solid layer. So what this, typically you do that in a bath with the part fully submerged, and you just have an electrode in the side, and the current flows to the part more or less evenly. What this process is now doing is it's just a tiny tip. So basically, I guess it could be more or less submerged still in the in your plating solution, but it's just because the tip is so close to your part, you get the most amount of current going to that area where the tip is.
It's kind of reverse EDM machining.
Yeah, basically.
Basically. Yeah, but it would be interesting to know if you could also just use like a very small. Well, the thing is, I think you can't really use a small tip electrode because that electrode will, I think, slowly dissolve away. So having this, like the current,
True. Density?
Kind of the flow of current and limited
density.
by the nozzle, by the plastic nozzle itself. Current density limited by the plastic nozzle itself could just overcome that problem.
Yeah. What I'm really questioning here is this fast enough to be usable? Because if you plate, for example, with copper, like you can get in the order of magnitude of microns per minute. And that's if you fully submerge your entire part in the solution. That is doing literally the entire surface of the part. Now, if you just do a tiny tip, you're building microns per minute on that one spot where the tip is. So I'm guessing this process really is something that they're showing super tiny prints here, basically printing on tracks, conductive tracks onto part essentially. For that, yes, can definitely work, but it's not like you're gonna print a Benchy out of copper with this process. That's gonna take years probably. So that's something you have to keep in mind. It can print on conductive tracks or super small features, but it's not gonna really make a physical part. The part already has to be there.
Yeah, but still, maybe we see some more development in that direction.
Yeah, it's another tool in the tool bag, right?
Yep.
It's really great to see. And another tool in the tool bag is the upgrade for 3D printers that saves time and support material. So this is from the, oh god, what does ZHAW stand for? Zürich Hochschule für angewandte Wissenschaften?
Yeah.
Guess I got that right.
Zurich University of Applied Sciences?
Yep.
Probably.
Who built a Prusa with a rotating nozzle that is now tilted at 45 degrees. So you have your print and the nozzle, so it's an extra movement axis on the printer, and now the nozzle can swivel around your part, and basically it always deposits at 45 degrees, kind of like the belt printer does, but now you can adjust that angle. So yeah, what they're showing off is like the typical mushroom that is a perfectly horizontal overhang on the sides. Basically you just print that as radial layers, and you print you always just have a 45 degree overhang for everything. And that sounds really interesting, but also really tricky.
Tricky in terms of, I think, software once again. So there was a bit of discussion on that on Twitter, and there's also a paper released about the process itself. They do. Adrian Boyer was discussing with the guy on Twitter.
Yeah.
They're kind of defolding the model that it is, or transforming it, that you can slice it better, and then it's working for that more or less 4-dimensional 3D printer. This is, as far as I have understood, not something that you can just put any model in there and use it right away.
Yeah.
It's not available publicly. Hopefully it will, because Adrian Boyer, I think, also said, if you guys want to open source it, I'm happy to help you out in that regard.
Yeah, and they weren't immediately going, oh no, we're patenting this and we're locking this down. No, this is ours. Yeah. No, they were very open to the idea. So thumbs up for that. They
just said they don't have any experience in that regard.
Yeah.
So in regards of open sourcing something. Again, hardware, I think it's not too hard to have a platform that can do 4D, 3D, 4D, 5D, 6D movements. In the end, it still again comes down to software, and hopefully at some point we have something that we can use to work on things like that.
Yeah. So right now, what it looks like, what they're doing is they're basically they're doing conical layers. So what they're transforming their models into is basically a model that is just cones stacked on top of each other, and the nozzle is always like perfectly swiveling. The nozzle is always pointing towards your center, the center of the part. So the further you move out, nozzle orientation doesn't change, but as soon as your axis off of center, you get what I'm saying. It's the nozzle is basically always pointing inwards, and your layers are cones. So you're always printing perfectly perpendicular onto your previous layer. Now, what could be already done from that is if you don't just have the cone shape, which is, I guess, easy to transform your parts for slicing into. If you don't just have cone shapes, but you, for example, what Adrian Boyer suggested is you always center it onto your, what was it called? Like the center of mass, or the center of area of your layers. So if you have like a cucumber shaped object, you always center it towards the center line of that cucumber. That one. And then also, I don't know if the physical geometry of the nozzle currently supports it, but what you could also do is you could say, okay, this is a cone, and we're cutting that off, and from this, so that they can do inwards and outwards cones. And you just say, okay, for these layers, we're doing the inwards, and now the overhang's going the other way. We're doing the outwards cone printing. There's so much. And if you read the thread on Twitter that Adrian is involved in, there is so much potential in just optimizing for that. And as always, it comes down to what can the software do and not what can the hardware do. Because the hardware is, honestly, it's trivial. We have 4-axis boards. We have, we can build spinny hot ends. It's not a problem at all. It is really, how do we slice for this? As it always is.
Yeah, definitely. So the thing is, those guys are just like 1.5 hours of drive away from me. If COVID wasn't there, it would be really nice visiting them. But I don't know. Maybe there's some research in that direction. Maybe there's an opportunity to, at some point in the summer, go and visit them and see what they're doing and really see it hands-on, how the slicing process works, how the preparation process works, and then really how the layers come down and what challenges they still need to overcome to make that more generally usable for, I'd say, like generic parts.
Yeah, just the
generically formed parts.
Which, that's the software part of it.
Yeah.
Yeah, so another tool, another approach that, maybe it's going to get used, maybe it's never going to get used, but it's something that could solve a lot of problems. And just in case it wasn't clear what this was all about, it's about being able to print geometry that you would require support material or other ways of modifying the model to make it printable. So this would allow you to print almost all geometry except for negative overhangs. We're trying to start in midair. So, yeah, cool stuff.
Other things that are or will come quite close to us: 3D printed food. 3D printed meat substitute product should be available in the first quarter of 2021. Here in Germany.
In selected restaurants.
So at first I thought this was also like lab-grown meat that was then extruded into a meat-formed part. But yeah, when you read the article, I think this is an Israeli company. They are doing like basically vegetable-based meat substitute, and then just print it in a shape that it looks red and white for like fat structure and muscle structure, and maybe even, I don't know, cartilage or something like that. if that is available, and I think it should be available at least in Munich or something like that, I would really like to try it out and see if it tastes any different as the Beyond Meat and Impossible Meat and other meat substitute that have become pretty popular over the last years.
Yeah, I mean we've talked about the Impossible burgers and all those that you can just buy in the supermarket when they're available.
Yeah.
Much of the stuff isn't particularly great. I don't think it's actually the texture that's lacking, or the I guess the texture. Like if you have a steak, it's not just one uniform material, as a burger patty would be when it's minced meat, but it's just the basic material that they're making their substitute material out of. 3D printing doesn't really help with that. Maybe it can fool you into accepting it more as a real meat if it does have some texture to it. But to me the core challenge is still it just needs to taste right, and the because I mean burger patties, minced stuff is the easiest thing you can do, because it's literally minced. It doesn't have any defining texture to it. Get that right first, and then look into shaping. I don't know.
We'll see. I hope to maybe try it out at some point.
Yeah.
If restaurants open again.
God, right? Yeah, that's. I didn't even think of that. I was like, oh yeah, it'll be great when it'll be available, but sure, restaurants need to be open for that too.
Well, yeah, maybe they have it as takeaway.
I was gonna say
getting takeaway from Munich is kind of hard for me.
Yeah, it's same for me, but you're a bit further away.
Yeah, could eat it in my car.
Just park in front of the restaurant and chew away. Yeah, but definitely interesting what they're doing here, and it's good to see that this is being worked on. I mean, meat consumption, major issue for just the destruction of our planet. So if we have something that is maybe a bit less destructive, that's good. On the topic of being destructive or not, who was it? Simone asked on Twitter recently, like, do you think PLA is or would you consider PLA to be environmentally friendly? And I think that question was intentionally open-ended. Would you say PLA is environmentally friendly? And
maybe
that was my answer
friendlier, maybe friendlier than other materials, but it's not helping the environment. It's still taking up resources in terms of food that others might be able to eat. It is producing CO2 just by the process of growing it, harvesting it, and everything what is connected to it, making PLA out of cornstarch. And then in the end, it releases its taking up CO2 again when you burn it or you just dump it somewhere. I think the thing that might be more environmentally friendly is that it might degenerate in a quicker amount of time if you compost it or put it in a dump in comparison to PE, ABS or whatever. But in the end, it's still not environmentally friendly.
Yeah.
Also, yeah.
Okay. Couple notes on that. So first, the first thing that I think Adrian Boyer again brought up is any sort of plastic is captured carbon. So whether that's ABS or poly, whatever, it all has a carbon atom in there. And with fossil-based plastics, you have captured carbon from a couple million years ago, and with plant-based plastics like PLA, you have captured carbon from when the corn was grown. So essentially, as long as you have your spool of PLA sitting on the shelf, it is carbon capture and storage in a plant-based way, more or less. So in that regard, it is actually pulling carbon out of the air. It is a net carbon reduction. the other thing that was brought up is, first of all, I mean, the PLA doesn't really compost in a regular compost bin, but when it is industrially composted, or I guess, what's the word? Basically, when it is processed in an industrial composting situation where it can be composted, it also releases methane, which you probably should capture and burn, because once you release methane, then you have a factor of 50 to 100 more environmentally dangerous or impactful than the CO2 itself. So it's, on the one hand, it is actually net capturing carbon, but on the other hand, it is potentially releasing the methane once it gets dealt with, I guess. So 2 points, but so your point is absolutely valid. There is energy being put into the production of PLA, and yes, it is competing for crops that could be used for food. Would it be better to just use recycled PETG, for example? Possibly, right? If you have a high degree of recycled material in there.
Yeah, of course, because then you kind of keep the circle just going. You for the recycling process, you again need a bit of energy.
Sure.
But it's probably less than making PE just from grounds up.
Yeah. I think I might be misquoting this, but for example, bottles, reusable glass bottles, Mehrwegflaschen, versus single use, like the thin wall 25-cent Pfandflaschen, it is actually less energy intense to shred and remelt those thin PET bottles every single time you use them versus melting down the glass bottles after, I don't know how many, 25 or 50 uses. So the plastic recycling process is not that energy intensive, and it is not inherently releasing any CO2. It's just energy which you could, use renewables for.
Yeah.
So in my mind, like PETG, if it's recycled and, you don't just throw it out, you actually collect it and recycle it. That would be the ultimate one, right?
But the question is, PET is not equal to PETG. Is there enough like industrial PETG waste to make filament out of it? Because making filament out of PET bottles works, but it's not a great material to work with in the end. The question is it actually environmentally friendly to have PLA filament sitting on your shelf or even printing parts out of it, because it basically captures CO2? The question is, how much energy do you need to make 1 kilo, or how much CO2 do you produce for 1 kilogram of PETG, and how much CO2 was taken up by, how much CO2 is basically stored in that roll of filament? That would be an interesting question.
Yeah, if somebody has data on just how PLA is, first of all, the PLA resin is produced, and then, how much energy it takes to put it into filament, and then, of course, everything that's attached to that, shipping, logistics, all that. That would really be interesting. So if you have any info, leave a comment below.
Yep.
On the topic of comments. Oh no! Well, one more feel good story before we get into the comments today. You've seen Chelsea Kearney. God, I'm sorry, I'm bad with names. You've seen Chelsea's Bernie model, which is, Bernie in mittens, the meme we all know about. And she actually made a really high detail 3D model from it. And Joel printed it on a resin printer, I think. And Resin, known from shows like Corridor Digital or Corridor Crew, he used that in a quick render and just used it as a joke, more or less. I mean, that's what the internet is for, right? But he basically used the original 3D model that Chelsea made for 3D printing and had textured, which you typically don't need for 3D printing, but he just used that model for 3D graphics, for 3D rendering. So my entire point to this is it is really good to see that 3D printing has so many more little bits going to other disciplines where the tools and the assets we create for 3D printing are usable for other people too, not just for 3D printing folks. Yeah. So we're gonna.
It's just great to see, especially when you turn the sound on and have that sound of like a gymnastic ball, like just one of those gymnastics balls, big ones, bouncing around, and all those. Bernie say, great work, Chelsea there.
Absolutely. Yeah, we're going to link that tweet below, obviously, and you can click through to Joel's video and to the original model. Yep. Great stuff.
All right.
Let's actually leave these two for the next time, I think.
Yeah.
Yeah, we've got plenty of stuff to talk about. Let's get to a couple questions from Simon A. Hey, what controls the depth of cure in an LCD style printer? Say you printed a 20mm hole followed by a 10mm hole on the Elegomos. What stops the light from the 10mm hole semi-curing the layers above? How does it achieve a clean plane? A 20mm hole followed by a 10mm... Yeah, I mean, it's basically why aren't the rays of light just going through your print and just curing columns?
Well, I guess because they are absorbed by the photosensitive. Did you watch the resin video? Photosensitive compounds that are in there?
The resin video? Which resin video?
From the resin science guy.
That one.
We talked about last time. No, you didn't.
No.
I would say it is absorbed just by the resin, and doesn't really penetrate that deep into the material. And also what we talked about last time, since it's not focused, I think it will spread quite quickly,
especially on
the
an
intensity.
LCD printer.
Yeah, exactly. So I guess the intensity will be decreasing very fast as soon as it comes out of the LCD and enters the resin, due to absorption and is that diffraction?
Yeah, not necessarily. It's just it's not a focused beam of light to start with.
Yeah.
The thing, of course, is you can print different layer heights on an SLA printer. On an LCD SLA printer, you can have it penetrate into your resin a certain length. Now, I am not sure how the physics of that work exactly, whether the layer starts curing from the LCD up, and basically you start with, I don't know, a couple of microns of cured resin, and that, because that is already cured, stops absorbing your near UV light, and then it can grow upwards if you so wish, basically. So it doesn't cure like the entire, I don't know, 50 micron layer at a time, but it basically grows from the bottom up. Yeah. Don't know if it does that, or if it is simply because the intensity of light decreases the further away you are from the LCD, as you mentioned. And then if you cycle your layers faster, you don't fully cure that area of the print that is further away from the LCD.
Yeah, I'm not 100% sure. I think that's not the case, but you also have, well, the resin that's the what's the sheet called?
FEP.
The FEP sheet is semi permeable for oxygen, and oxygen also plays a role in there. So I don't know if I think that's not the case for standard resin printing.
Not for these, I think. Yeah.
If somebody has an idea why we don't like cure very deep into the resin, maybe let us know. I think with absorption, it's kind of plausible if you have an opaque resin, but if you have a translucent resin, you can see the UV light if you take a look at the part when it's being printed.
Definitely. Yeah. But it does work. Like, it's one of those things we brought up, possibly. Maybe it's something entirely different. If you know better, let us know.
Yeah, definitely. All right. Second question. Sorry, I don't.
Okay.
Just messed up my
Adam,
document.
let me fill in here. Adam Phillip asks, looking for a cheap closed loop NEMA 17 motor for printers. Can you recommend a model? So I've not used any closed. Well, no, I don't think I've used any closed loop steppers here, but I know that there are several different solutions to get a closed loop system going on a NEMA 17 size. The first thing I've seen is just little add-on boards. That was 10 years ago or something. Little add-on boards that you can just put on the back of your printer that has a magnet or some sort of an encoder on there, and it's just feeding back into your stepper driver. So that's a whole system of the add-on encoder and your driver, and then that corrects for that. But what's coming up more recently is stepper drivers that have an integrated stepper motors that have an integrated driver to them. And you can actually get different types. So you can get the stepper motor with just a little PCB on the back that has the encoder and driver and everything on it, and you just give it step and direction. And I guess that works, but it's at its core still a stepper motor. Or you can actually get servos, like actual servo motors in a NEMA 17 size that have the driver and everything built in as well. The closed loop NEMA 17s are like $20 ish, so they're not that expensive. The servo types are, I think, $60 or $80. But of course, the servo is going to give you, I guess, lower resolution but much higher performance if you really want.
But less holding torque. But basically no holding torque.
True. Yeah, it would have to constantly correct for that. The question is, do you really need holding torque in a 3D printer? You're not milling anything where you have external forces on your tool head, I'd hope. So really holding torque you don't need, actually. It's just
for the Z-axis you would, yeah.
Well, I mean, the Z-axis on my printers aren't dropping by themselves either, so.
Yeah, true. And depending on the amount of oscillation you will have for getting some basically holding torque on a servo motor, it could work as well. And usually on real servo motors you have a brake that engages as soon as there's no movement.
True. Though one thing to bring up with holding torque real quick is a stepper motor doesn't actually hold in one position. A stepper motor is also elastic in both directions because it has, obviously, when the shaft is standing still, there's zero torque on it or it would spin. Yeah. So it basically relies on the holding torque is proportional to the deflection from its zero position. So it's got maximum holding torque just before it skips a step. So yeah, if you have any stepper motor is elastic, which is why 0.9 degree motors are so great, because they basically have only half as much deflection needed to produce the same amount of holding torque as a 1.8 degree motor. Okay, just a bit of a tangent there.
The first question is either why are these motors are pretty cheap, like $15 to $20. Why are not all printers using closed loop stepper motors? Yeah, that's the question.
Okay, because we don't need them. Because like especially on a cheap printer, like a stepper motor is how much if you buy them in bulk? Probably $5, versus 15 or 20 for the integrated one. It is a cost factor, and regular stepper drivers are dead cheap. Though we could probably make the integrated stepper motors with the little PCB on the back. You could probably make those for not much more than it would cost to have a a regular stepper and a driver. But really, it's tangent incoming. No, it's one of those things where you could have innovation, but because of the goal of having of developing and manufacturing 3D printers right now is just they need to be cheap. There's almost no room for actually doing something novel anymore. It's just we do the same things we've done 5 years ago, and we try to do them at a lower cost. That's essentially what's happening, except for maybe the PCBs, the control boards, and the LCD screens. Those are getting better, but everything else is just the same. So I guess that's why we're not seeing much of them.
Yeah.
So yeah, to close out the question for cheap closed loop NEMA 17 stepper servo motor for printers, just those with the integrated PCB on the back. I've not tried them, but they seem to be pretty decent. So you've put in the big TreeTech S42B.
Yeah, I've just seen a video from Teaching Tech on that one. Seemed to work, but I have also never worked with one. I 1.5 years ago I backed the ananas stepper thing on Kickstarter, but it hasn't arrived yet. I constantly get update emails. Our developer went to another company. I don't know if they will ever arrive, but they were also more expensive than the big TreeTech ones. So I don't really see that there is a market for them anymore. It was more enclosed than the big TreeTech one, but I think you also get housings for this one. I see more use for them in CNC machine. In CNC routers, for example. Yeah, where
you actually have external forces.
You have external forces, and skipping a step can be really bad.
Yeah. Well, 3D printer, worst that's going to happen is you have a layer shift. Typically, you're not going to break anything.
Yeah. Cool. All right. Last question. Scott Bader. So Scott Bader is asking, did you put in new cameras? Seems a lot cleaner than previous episodes. Good discussions. Our setup changed, but actually not really into the, I would say, optically positive direction, at least for me.
To be honest, your image looks, I've pointed it out last time, your image looks fantastic. The lighting is just really good. You've got the really nice softboxy light coming from your camera left. You've got a nice background. Your image looks very pleasing. Just want to put that out there. I've got the hard edge light here because I typically don't look this direction. This is my set rotated. But yeah, we did change setups. We did change the way we record these podcasts. We're now doing it in a more live setup, which makes editing these things so much easier because we don't have to deal with syncing up 4 different tracks. It's now going into OBS Studio. We've got a video capture through Zoom. We've got audio through Studio Link, and I'm recording here on the GH5 going into the recorder or into the computer. Stefan's coming in through Zoom, so Stefan's image actually looks super soft. It almost looks like a 480p image. Though honestly, for a podcast, it's fine. It's okay. It's just you see everything you need to see. And it is the same tech, just new setup and downgraded in the quality we're recording at.
Yeah, I think if the audio is fine, that's totally good. Audio on my side could be a bit worse because I'm still in my new office. I don't have a lot of furniture in here. There are some panels that you can see right here in the back for that it's a bit less echoey, but it's still echoey in here, and I get some curtains and shelves and stuff in here to just make it a bit nicer for recording. So sorry for that. I hope that it's going to be better in the future.
I'm gonna process you in post a bit and take out the echo. So
I should really try out the RTX audio processing thing.
Ooh. It is impressive what it does. The RTX voice is extremely impressive in what it can filter out. However, audio quality does degrade. So you can clearly hear that it does sound processed and digital and warbly and all. So maybe not something you'd want to listen. I would rather have a bit of echo in the background than having to listen to that digital messed up voice. Even though it might be more clear to understand, but it's just not pleasing to listen to. Yeah, but you can actually get it to work on pretty much any card, not just the RTX cards. But you do have an RTX something.
I do have an
You should
RTX
sell that.
2070.
They're selling for crazy prices.
Seriously?
Yeah.
I was actually thinking at the end of last year to buy a new workstation, but it's hard to get anything at the moment.
Yeah, I've
at
been,
a decent price.
I've been wanting to get a 3080 or something, but like I'm not gonna buy that for 1,600 euros. You can forget about that. But yeah, for example, my not RTX, my AMD 5700 XT, I could sell that for more than I bought it new right now.
But then I wouldn't have any graphics card anymore. Doesn't mean that I game a lot at the moment, but I still kind of need something.
That's in my gamerish PC workstation, still rocking the 1080 Ti. So yeah. Well, I need the hardware, so I'm just putting it to use, mining some Bitcoin right now. So.
Yeah.
Why not? Solar power is cheap, so. All right. Good episode.
That's it for today. Thank you all for watching. If you have any questions, put them down in the comments for us to discuss. Tweet them to us at the Meltzone. If you want to support us, there are our Patreon links down in the description. And I think there's not really that much left to say as thanks for your time, Tom.
Subscribe.
Get subscribed.
Yeah. Thanks, Stefan, for the time.
And see you guys in the next one.
See ya. Bye.
Bye.